The real power in Java is the ability to create objects, and that's what you learn in this lesson. So far, we only worked with primitives like int, boolean, float, etc. Primitives are great for solving mathematical equations. But an application like Amazon website needs more constructs than just primitives. There are shopping carts, customers, books, toys, cookware, CDs, etc. And you need a way of representing them. With the current knowledge, if you are asked to represent two customers who visited your website, you would probably do so like the way it is shown here, with all the attributes of a customer grouped together and a comment line making it clear for someone to understand. Notice the variable names that are given here, like name 1, name 2, customer ID 1, 2, address 1, 2, total 1, 2, etc. This way of representing customer is okay in small applications, but for very large applications, your code becomes very unwieldy and difficult to manage. So, what is the solution? Let us first understand and classify a few things. Now, Jane and John are customers. Also, Jane and John are specific instances of a customer. And every customer instance has a unique set of values like name, customer ID, etc. This basic classification is the foundation on which object oriented programming concepts are built. There are many programming languages which support object oriented programming, and Java is one among them. In OOP, real world entities are objects. Customer, shopping cart, book are generic templates. Using the generic templates, you create specific object instances like John, Jane, etc. In Java, a class represents the generic template using which you create specific object instances. And here is how our customer class would look like to hold all the values that we have used earlier. Now that we have the customer class defined, we'll remove the earlier way of representing the customers and replace that with objects. Cust1 and cust2 objects are created from customer class by using the new keyword. So the new keyword is applied on a class to get an object instance of that class. It creates the object using a construct called constructor. However, our class definition does not have a constructor defined. Since the constructor that is used is a no argument constructor, it uses the one that is present in the top level object class. So the point to note here is that there is an object class which is part of the Java API, which is the origin of all classes. Every class inherits this class implicitly. You will learn more on inheritance later, but for now, it's enough to understand that the no argument constructor is inherited from the object class. Here is the cleaned up code with two objects created from the customer class. Let us now understand the first object creation in detail. We created an instance of the customer class and referred that object using the cust1 variable name. Then we set values to instance variables of the customer object. Let us understand a few things that happen in your random access memory when you run your program. First, the class template is loaded, and when a new instance is created using the template, a separate memory space is allocated to keep the instance object and its values. When an instance is created, it fills all the instance variables with default values. And in the default values, notice that the string is null, integers and doubles are initialized to 0. And then when you start assigning specific values in the code, the default values get updated. So when all the statements are executed, you will have two objects created and initialized with specific values in memory.